In this section of the CISSP Certification Course, we are focusing on Domain 8, Software Development Security. Specifically, we will address how to define and apply secure coding guidelines and standards. Our primary focus is on 8.5.1, which deals with identifying and rectifying security weaknesses and vulnerabilities at the source code level. Understanding these weaknesses is paramount to safeguarding your applications from potential threats. We will explore the common pitfalls developers encounter and discuss best practices to mitigate these issues. By adhering to these guidelines, you will significantly enhance the security posture of your software projects, ensuring they are robust against attacks and vulnerabilities. In this section, we will introduce the foundational concepts of secure coding. Secure coding practices are vital to ensuring the robustness of software against potential threats. In the context of software development security, secure coding is instrumental in safeguarding applications from myriad vulnerabilities at the source code level. Our main objectives here are to understand the various common security weaknesses that can be present in source code and to learn effective strategies to mitigate these vulnerabilities through established secure coding guidelines. By adopting secure coding standards, we can significantly reduce the risk of unauthorized access, data breaches, and other security incidents. Let's make sure we grasp these essential concepts as we move forward in this domain. Let's dive into common security weaknesses. These are vulnerabilities that can compromise the integrity and security of your software application. We'll focus on three main types today: buffer overflows, SQL injections, and cross-site scripting, XSS. Buffer overflows happen when data exceeds the memory buffer capacity, potentially allowing an attacker to overwrite adjacent memory. SQL injections allow malicious users to execute unauthorized SQL queries, leading to potential data breaches. Cross-site scripting involves injecting malicious scripts into web pages, which can then execute in the user's browser. The impact of these weaknesses can be severe, ranging from unauthorized access and data breaches to denial of service, DOS attacks, that disrupt service availability. Understanding and addressing these vulnerabilities is essential for maintaining robust software security. Buffer overflows occur when data exceeds the buffer's capacity, leading to the overwriting of adjacent memory. This often results in unpredictable and potentially harmful behavior. For instance, take the example shown, char buffer 10, starkspy buffer, this string is too long for the buffer. In this case, the function starkpy copies a string into a buffer that's not large enough to hold it. This causes the excess data to overflow into adjacent memory spaces, which can corrupt important data, create security vulnerabilities, and lead to runtime crashes. Understanding how buffer overflows happen is essential to grasping how these vulnerabilities can be exploited and the importance of strategies to mitigate them. On this slide, we'll explore strategies to mitigate buffer overflows. Here are three key techniques. 1. Boundary checking, ensuring that any data written to a buffer does not exceed its allocated size. This requires strictly defining and checking the boundaries of the buffer before writing data to it. 2. Safer functions. Instead of using functions like strpy, which don't check the buffer size, opt for safer alternatives such as strandpy, which limits the number of characters copied to the size of the destination buffer, preventing overflow. 3. Compiler protections. Leveraging compiler-based protections, such as StackGuard, which adds a security layer by injecting canaries into the stack that help detect buffer overflows and prevent malicious exploitation. These measures can significantly enhance the security of your code, making it more robust against potential overflow attacks. SQL injection is a technique where an attacker manipulates SQL queries to gain unauthorized access to data or execute unwanted commands. This can lead to significant security breaches, often allowing attackers to retrieve, modify, or delete sensitive information. For instance, consider the example provided. Select tau from users where username equals admin or 1 equals 1. This query can break security measures by exploiting vulnerabilities in the code. It's vital to recognize these threats to implement appropriate countermeasures and protect your systems from such attacks. To prevent SQL injection attacks, it's essential to adopt certain best practices. Firstly, use prepared statements. These ensure that SQL queries are structured in a secure manner by separating the data from the code, making it impossible for attackers to manipulate the query. Additionally, employ parameterized queries. By binding user inputs as parameters rather than embedding them directly into SQL statements, you effectively safeguard against manipulation. Lastly, always validate and sanitize user inputs. This process ensures that any data submitted by users is clean and conforms to expected formats, reducing the risk of harmful injections reaching your database. Adhering to these strategies will significantly bolster your defense against SQL injection vulnerabilities. Cross-site scripting, commonly known as XSS, involves injecting malicious scripts into web applications. These scripts can steal session cookies, deface websites, and cause other types of damage. An example of this might be an attacker entering script alert XSS script into a website input field, leading to the execution of the harmful code within the user's browser. Understanding how XSS works is essential to protect your applications from such attacks. Defending against cross-site scripting, XSS, involves several key strategies to enhance your web application security. First, it's important to encode output data. This means converting special characters to a safe format whenever you're displaying user input on a web page to prevent execution of malicious scripts. Second, using security libraries such as OWASP's Enterprise Security API, ESEP, can significantly reduce the risk of XSS attacks. These libraries offer built-in functions for encoding and validation, making your code more resilient. Lastly, implementing a content security policy, CSP, adds another layer of defense. CSP can prevent many types of attacks, including XSS, by restricting the sources from which scripts can load. These strategies work together to mitigate the risk of XSS and ensure a more secure user experience. Secure coding is a critical aspect of protecting your applications from vulnerabilities. In this slide, we focus on frameworks and standards that can guide your secure coding practices. The OWASP Secure Coding Practices document provides a detailed checklist specifically designed for writing secure software. It addresses common risks and offers practical solutions that developers can implement. The CERT Secure Coding Standards go further by covering not only web applications, but also different programming languages, ensuring that secure coding principles are applied across platforms. These standards offer comprehensive guidelines and example-based instructions. Lastly, the ISO IEC 27034 standard presents a broad framework for application security, integrating security throughout the software lifecycle. It helps organizations develop software in a secure manner, ensuring that security considerations are embedded in all stages of development. Familiarizing yourself with these frameworks and standards is essential for building resilient applications. In this slide, we'll be focusing on the OWASP Top 10. The OWASP Top 10 is an industry standard for web application security. It provides a list of the top vulnerabilities commonly found in web applications and offers guidance on how to mitigate them. Some of the key points include vulnerabilities like SQL injection, cross-site scripting, XSS, and insecure deserialization. Understanding these vulnerabilities allows developers to implement more robust security measures, ensuring that their applications are better protected against potential attacks. By following the OWASP Top 10 guidelines, you can significantly improve your application's security posture and reduce the risk of exploitation. On this slide, we're focusing on secure coding practices. These practices are essential for building secure web applications. First, let's talk about some key practices. The principle of least privilege suggests that users should have the minimal level of access, permissions, rights, and privileges necessary to perform their job functions. This helps limit the impact of a potential security breach. Defense in depth is another important practice. It involves layering multiple security controls throughout the IT system. This way, if one layer is compromised, others still stand to protect the system. Input validation is crucial for ensuring that all incoming data is validated, sanitized, and properly handled. This practice helps mitigate risks such as injection attacks and cross-site scripting (XSS). To assist with these practices, various tools can be employed. Static analysis tools, like SonarQube, analyze code without executing it to find vulnerabilities, code smells, and other potential issues. Dynamic analysis tools, such as OWASP ZAP, examine the application during runtime to identify and diagnose security vulnerabilities. By implementing these secure coding practices and utilizing the right tools, you can significantly enhance the security posture of your web applications. In this example slide, we'll be focusing on the usage of static analysis with SonarQube. The command sonar scanner-snar.project key equals my project is used to initiate your project. By integrating SonarQube into your continuous integration pipelines, you can monitor code quality consistently. The benefits of using SonarQube for static analysis include the identification of code smells, which are indicators of deeper problems in the code, and early detection of vulnerabilities. This proactive approach helps in maintaining high code quality and enhances the overall security posture of your applications. Let's consider a real-world application to put our understanding into practice. In this scenario, we need to detect and fix a buffer overflow in a C program. This is a common vulnerability that can lead to serious security issues. The best practice to handle such situations is to always validate buffer sizes to ensure they do not overflow. Additionally, using modern languages, which have built-in protections against such vulnerabilities, can greatly enhance the security of your code. This approach helps in mitigating risks and maintaining a high standard of code quality. In summary, it's evident that secure coding is essential for the safety and integrity of your software. It's important to have a solid understanding of common vulnerabilities, such as buffer overflows, and how to effectively mitigate them. By implementing best practices, such as always validating buffer sizes and using modern languages with built-in protections, you can significantly enhance the security of your code. Remember, using the right tools and adhering to secure coding standards is imperative to maintaining robust and secure software. To deepen your understanding of secure coding, I highly recommend exploring these additional resources. The OWASP Secure Coding Guidelines provide a comprehensive set of best practices for developing secure software. You can access them at the provided link. Another valuable resource is the CERT Secure Coding Standards, detailed in their wiki, which offers guidelines for secure software development. For an in-depth examination, The Art of Software Security Assessment by Mark Dowd, John McDonald, and Justin Schuh is an excellent book that covers various aspects of software security assessment. These resources will strengthen your knowledge and help you implement secure coding practices effectively. Thank you for your attention. Next steps. Continue with further modules on Domain 8. This will expand your knowledge and skills in secure coding practices. Implement what you've learned in your ongoing and future projects to ensure robust security.